in the wrong room, there is opportunity to leave. I would like you to stay there. Because I'm quite amazed that so many people come here to hear about the latest generation of ora12crac, which for all practical purposes is 11.203. So I will be talking about 11.203. No, just kidding. Please keep seated. Of course, latest generation in this open world means Oracle 12c. And I have with me here John McHugh, the Oracle Cluster Web Product Manager. And we will be talking about ora12crac 12c. My name is Markus Michalewicz. I'm the Oracle Product Manager for ora12crac. And this is what we are going to talk about. I will give you an overview about Oracle 12c. And every time I introduce a new version for ora12crac, and I've done so twice now, it's hard for me to figure out what am I going to pick and talk about, so you would find it interesting to go home and test it. This year I've chosen to talk about the areas where we have improved, and I will walk you through the features which have contributed to the improvement. And that's why John is sitting here, because with ora12crac 12c, even with 11GLEs2, we really talk about a stack when we refer to ora12crac. It's not just anymore the database, it's a real stack that consists of the database of Oracle Clusterware and Oracle ASM, which is combined in grid infrastructure. This stack provides you with better business continuity and high availability, better flexibility and agility, standardized deployment and patching, better data center integration and management. All these things we have improved with the Oracle 12c rack stack. I'm going to walk you through them and show you some features. And we have one addition for this year. The ora12crac stack is really valuable for any application, and we will be showing you in the end, leading over to another presentation that we have, what that means and how you can use the rack stack outside of the database. Now, I want to say something up front before I go into detail. In the course of this open world, we have had a lot of questions at the demo grounds asking us how ora12crac would work with pluggable databases, which were announced on Monday by Mr. Mendelsohn, for example. I won't have this in this slide deck, so that you wouldn't be disappointed. I encourage you to come to the demo grounds, which are opposite side of the room here, after the presentation and tonight, and we have a rack demo there which talks about how rack could work with pluggable databases. So if you are interested, I'll be there 2 to 4 today. Please come and see us. John will be there. He will be talking about clusterware. He will be talking about the things that we are going to introduce. So please see us there. That said, let's see what we have done regarding better business continuity and high availability. But before, let's remind us that 12c isn't out yet. So I have to show you this safe harbor statement saying there may be changes into what I'm introducing right now. And I also want to remind us what ora12crac stood for before 12c. ora12crac has always been the ideal solution for your database cloud. It has always provided a great business continuity and high availability, and flexibility and agility and performance and scalability. However, if you look at what we did, we made it easy to add a node to extend the cluster, or we also made it easy as part of standard deployment and management to add another cluster and then deploy another application on this environment, which we call the ora12crac stack. And that way we have given you a standard deployment, and we have given you all the features, all the capabilities that I've listed. However, the granularity level may have been a little bit high, so we could have done a little bit better in this area. And we have also received from you some feedback that told us how to improve. And this is what ora12crac 12c is all about. Improvements in areas we have already been strong in. So the new ora12crac 12c provides better business continuity and high availability on every stack that I've shown you. Oracle Clusterware, Oracle Automatic Storage Management, which are combined in Oracle Grid Infrastructure ever since 11GLEs2. And then on top, the Oracle Database, which is actually the layer of the Oracle rack by itself, the cache fusion, all the things in the database reside. ora12crac, in that matter, has been very stable, and a lot of these features I'm talking about here today will be more on the lower level, but you will see as we go. We have also enhanced the stack with a few new other things. If you want to look on your right or your left, there's centralized management that I'm going to talk about. And I'm also talking about a new symbol that you see there under the CRM application on the top right. You will be seeing what that means in a minute. Now, all these enhancements we have done, using a standardized and improved deployment and management. I'm going to talk about this, and it's very important to me to mention this, on a familiar and matured high availability stack. One of the main feedback we have received for 11 Release 2 was that a lot of the features we introduced were very useful, very helpful, yet they were a major change. So with 12c, we're trying to pick up those features and enhance them to provide even better business continuity, for example. That said, one of the major feedback we have received with RAC, and I believe some of you already know this, is that we have always been very good in prepare for unplanned downtime in a way that if an instance fails, we would still provide database service to the application. However, where we could have improved was, if an instance fails, it might have been that depending on the application you used, the instance failure may have still led to errors, although the transaction in flight at the moment of failure was actually succeeded. What that means is, if you had a transaction that was impacted by the instance failure, your application that you used may still have reported an error to the user, even though the database itself was still available through other instances as shown in this picture. Now, if we do this, if we break a transaction while it is actually in flight, this can result in multiple orders, for example. So you get 20 pairs of socks even though you had ordered only one. Accidental orders, you get the wrong size, the wrong color, which is sometimes funny. Or a wrong order, you don't get stocks, you get stockings instead of socks. And also, the other feedback we have received was, well, okay, we have some unplanned downtime issues, but we have also planned downtime issues. What if you want to perform a rolling patch, for example, in RAC? There is still a lot of overhead in terms of preparation for this planned downtime. Services need to be relocated for new sessions so that we could throttle down the workload running on a server that we want to patch. So active work needs to be stopped transactionally on this server before we can actually patch it. All these kind of things were feedback that we have received and gathered throughout the years. With Oracle 12c RAC, and a new feature that was actually introduced just before this session here, application continuity, we have tackled those problems. With Oracle Database 12c and Oracle RAC, I'm happy to announce the first database ever to preserve commit outcome and to ensure application continuity. And that's basically text speaking for, if your in-flight transaction is running on an instance that fails, we will be able to recover from this failure so that your application, as shown here, will return a success to the end user, and the end user will not see the error. And how do we do this? We have introduced a new layer between the application and the database, instance in our case, or instances, which is called application continuity. And there was a session, I believe, at 10 a.m. this morning, which talked about it in detail. So for those of you who missed that, this is a little summary. For others, this may be a refresher. Application continuity allows us to protect the application from returning an error to the user, but make it happen that it will return a success. And if you tackle this problem for unplanned downtime, the nice thing about it is we have actually tackled it for planned downtime. If we can take down a node any time, that basically means you can perform server OS maintenance at any time, because your application is not impacted. So by doing so, we have tackled planned and unplanned downtime, which was another goal for 12c. We didn't only want to tackle one of the two, we always wanted to have both of them in mind, planned and unplanned downtime. Now, RAC provides great local high availability, as you know. If a server goes down, we will be continuing to run on other instances. However, if the whole site goes down, or the whole database goes down, for whatever reason, then we need to find a way to protect ourselves against it. A typical solution for this would be DataGuard, or more so lately Active DataGuard. And application continuity will utilize Active DataGuard. So if you have a database, RAC database in the first place, and for whatever reason this whole database goes down, if you synchronize this database to another destination with Active DataGuard, application continuity will handle these type of failures. How it works? Well, very high level, it works as follows. The application sends a request to the database. by using calls through the new layer, which is under the application. More precisely, it's a JDBC thin driver. In the first release of Oracle 12, it will be, application continuity will be available as a JDBC driver, more precisely JDBC thin. The Universal Connection Pool will have adopted it, and if you use WLS, WebLogic Server, you can also use it. So if you use one of these drivers, your application will make a call to the application, to the database through this driver, and we will maintain state so that if an instance fails, the application, but through the driver, will be informed about the failure with FAN, Fast Application Notification, a concept that we have had a long time. And the driver will then replay this failed transaction if so required, and it will behave very nicely for well-behaved applications based on Oracle connection pools, for example, or the drivers that I just mentioned. This is very high level. I encourage you to read about it more, or if you have the chance to talk to Carol Corraine or Michael TP on our demo booths across the street, so to speak. Continuing the idea of high availability, there was another layer that we have used to provide the same, at least from a storage perspective, which was Oracle ASM. Oracle ASM has been the storage management solution ever since 10G. And it has done a great job. It provides all the mirroring, all the distribution of data across disks on the disk storage. However, what it also had, it had the ASM instance running on each node in the cluster, at least with 10G, 11G, release 2. With Oracle RAC 12c, what we have done is we have introduced Oracle Flex ASM. And Flex ASM takes away the need to run an ASM instance on each node in the cluster. If you look at my little picture here, you will notice that the second node from your perspective left has actually no ASM instance running. This is the reduced overhead we are talking about. Flex ASM allows you to use ASM, but not to have an ASM instance running on every node in the cluster. In my case here, I have a 4-node cluster, and I have an ASM instance only on 3 of them, which would be the default. That way, your database instances can, run on every node, and they will access what we call a non-local ASM instance. If you remember, in 11G release 2, every node required an ASM instance because the database instances would have expected the node to have one. They wanted to connect locally to the ASM instance. With 12c, this goes away. With 12c, your database instances can actually use a remote ASM instance, which instantaneously leads to an improved database availability, because if an ASM instance can be used remotely, the failure of an ASM instance will actually not have an impact. Because if the ASM instance locally fails, what the database instances can do, they can use a remote database instance for their purposes and continue to operate. And again, that tackles unplanned downtime. Now the same holds true, however, for planned downtime. If you can take down an ASM instance anytime you want, you can do it for planned downtime. You take it down, and your database instances will continue to work by just using a remote instance. This is a very great feature. No other volume manager on the market has this kind of inter-node recovery in case it fails on a local node. How does it work? Very simple. If you remind yourself, the database writes always directly I/O. ASM is required only to maintain extent maps. So if the database needs a new extent map, or the extent map changed and the database needs to be informed about it, this is when ASM is involved. So having an ASM instance per node is really not required for most of the clusters, because it's not used for every I/O. It's just used if there is a change in data set. So that way we can reduce the amount of ASM instances running, we wouldn't have to synchronize so many, and your database can still write directly I/O to the database disks in Flex ASM. That's how it used to be. And again, one of the design features we had with 12c was utilizing what we had and improving upon it. So if you follow the bullets, the database can now connect to a non-local Oracle ASM instance, while the Oracle ASM instances serve the ASM extent maps, but the database I/O remains direct to disk. There are a lot of other smaller features on every layer that I'm going to touch on today. However, I'm unable to talk about all of them. I have chosen 2 for ASM just to show you what I mean when I say, well, there's a lot of small things we do to make a big thing better. One, for example, is the Oracle ASM disk scrubbing. What this is very simple. You can initiate a check for logical data corruption and automatic repair if you use normal or high redundancy. And the disk scrubbing would run every time you rebalance. Why is this important? Well, Oracle ASM manages ASM data files mainly, and if you use an ASM-based data file, you could have RMAN running logical checks on your database or other mechanisms. However, ASM can do it too, and if you do it on ASM level, it will also work for files that are not data files, such as files coming through ACFS and other means. So that way we have now a disk scrubbing utility checking for corruption for all sorts of data, and it will also, as I said, run automatically when there's a rebalance, protecting you from more corruptions or potential corruptions. There are further enhancements, two I have listed here, which I find very interesting. Enhancements to the Oracle ASM disk resync mechanism and the rebalancing. And the enhancements in this area are mainly to monitor and manage the speed of the operation. Let's make an example. If you have run in a rebalance, for example, you may have seen that we estimate the time how long a rebalancing could have taken if you rebalance a disk group. Sometimes you would have wondered why it would take 2 years to rebalance a disk group. So the prediction was a little bit off at times. We have improved this. So there is a new mechanism to monitor the speed and estimate the speed. And for resync, we are actually able to set a resync speed, if you want, similar to the rebalancing power, so that you can influence how fast or how slow you want to resync and what amount of CPU you want to utilize. Last but not least, especially for the resync, we have introduced a way to recontinue. So if a resync is interrupted, for example, because it failed or an instance was stopped, we will have put a checkpoint where we stopped, and we will resume the operation after it was, we could do so after it was resumed. These are areas that are very interesting. Other ones regard better flexibility and agility. And one of the things that really help you to improve flexibility and agility if you use Oracle RAC is policy managed databases. Now, some of you may know that we have already introduced policy managed databases with 11 release 2. So I want to ask you, who of you uses policy managed databases, please? Could you raise your hand? Oh, that's at least a good 3% of you. Not quite unexpected, as I must say. So that's why we are not saying what we improve with policy managed databases. What I really want to introduce you is a policy managed database mechanism that has undergone so many enhancements that we dare to say it's kind of new. So I encourage you to look at it. What we have done is we have improved our policy managed databases based on server pools to model all sorts of scenarios so that you can use it as demand requires it or as business requires it, which is to say, if you have a cluster where you run multiple applications and multiple databases against the application against multiple databases in this cluster, what you now can do is you can set up policies, for example, for different periods of a day. So under the day you have a night operation, you have a daytime operation, you may have an evening operation. You can set it by geographic reason, or you can combine it with having a policy to modulate or moderate the resources in the cluster so that after a failure you would still run with an optimized amount of performance in your cluster. Last but not least, you can set policies as the system requires it. And this is an example that a customer gave us. He said, I want to use my cluster in a way that I have one bigger node, which is why the node in the middle and the green server pool, the boxes in the back are server pools, are somewhat bigger. I want to have one cluster, one node in the cluster so that I can run my backup on that, because this node has, for example, my backup library on it. So all my databases should ideally be backupped on this particular node, and for that matter, I have designed this node to perform backups much faster. We have now a way for policy managed databases and server pools to understand that there is a certain server which may have certain capabilities and utilize those. How does that work? We have enhanced our server pool management to understand and actually actively utilize differently sized servers. As you may recall, we have always said that you can have differently sized servers, as in different capacity, more capacity, in your cluster. However, we also said if you have a server that is more powerful than the rest or a group of servers, you better make sure by manual assignment that you utilize it adequately or appropriately. Well, that doesn't really work so well if you have a policy. Your policy is based on server pools, and the server pools must then understand that you may have differently sized servers in your cluster. This is exactly what we did. Now what we do is we store server attributes per server in the cluster, and you can set up your server pools based on these attributes. Now again, this is a little bit of tech talk, so I'll make it simple for you. You can now create a server pool which hosts all your production servers which have a minimum CPU amount, and you can create a server pool which, for example, hosts your development environment, which may have a slightly lesser minimum requirement of CPUs, and then you have a third server pool that has another production database. And if, for example, a failure occurs, you can now make sure that only servers from the development environment are taken into a production server pool if they meet the minimum CPU requirements. Because most of our customers are not so concerned if they get more power than they need, more they don't get enough. So if you have differently sized servers, then you could model this. However, the model part goes beyond this. You can base it on expressions, so you can model really complex scenarios if you need to, but the simplest one is you can use servers as they are designed. Now, if you do a lot of automatic operation in your cluster, one feedback that we have received was we want to know how the cluster would behave if either a certain operation is issued or if a certain event is triggered. So what that means is the cluster can have a lot of resources. In my cluster here, I have one database, the red database A. I have two server pools, the red prod server pool and the blue mail server pool. And I could have the idea to move the server from the red server pool prod to the blue server pool mail. And when you do this, in a setup like this, which is based on policies, a lot of events can be triggered by a simple command which would say, relocate the server. So our feedback that we have received from our customers sitting in this room, I presume, is we want to know what happens if I issue a command with respect to resources being reallocated. We want to know what happens if a failure occurs in the cluster. With Oracle ora12c, the what-if command evaluation will give you this capability. You can use the what-if command evaluation, for example, to set up and validate policies. If you set up a policy, you have a certain idea of things in mind that should happen if a policy is activated. However, you want to test it. The what-if command evaluation will do this. It will evaluate what happens if you activate a policy, if you, for example, modify a server pool, or if you just do something on a resource. We have even an enhancement to this which will say, or which will allow you to simulate a failure and let you determine what happens upon failure of a component or a resource. Again, how does it work? Well, for my example that I gave you before, where I wanted to relocate a server, I have a certain server pool setup, which is basically importance 0 for both of them, minimum 1, which is to say each server pool should have at least one server running in it. However, my mail server pool should have a maximum server amount of 3, and my prod server pool should have a maximum amount of 2. So if I relocate a server from the red prod server pool to the blue mail server pool, I want to know what happens. So the command you would use is srvctl relocate server, and then you define the server which you want to relocate and to what pool. In my case here, Linux ora12 server 1 to server pool mail, and you add this -eval. And on DBA view, srvctl view, it will tell you what would happen to my database running in this server pool and potentially in the other server pool if so required, and it will give you this information. Now, on John's level, on clusterware level, it will give you even more information. It will maybe give you information on dependent resources if you had set them up. And John is probably going to talk about in his presentation later today at 3 p.m. What you can do with this tool. Now, this is all regarding the cluster. There are more things we did, for example, for standardized deployment and patching. And this has been a standing request. Our customers wanted a standardized deployment and patching, which is, of course, simple. Well, we have a new approach to this, and it may take a moment to get adjusted to it. So let me introduce a new concept, which is called the Oracle Grid Home Server. The Oracle Grid Home Server, and the name, I must admit, may change one more time. The Grid Home Server is a centralized management and deployment, or enabled centralized management and deployment of Oracle database and application homes. So basically what it is a centralized way to store applications and database homes, all but the OS images and the Oracle Grid Infrastructure home, which is why the name may be a little bit misleading. Now, on the other hand, I have the good news. We will be planning on having the Grid Infrastructure home also be able to reside on it. In that way, we may just as well keep the name. A little thing that we will figure it out once it's available. We can also put third-party software on it, but I will ignore this part for now. And what this gives you, if you use the Oracle Grid Home Server, you can actually deploy your database homes on this server, and your production clusters shown in the top right will be representing themselves to this Grid Home Server as a Grid Home client. That way, you can install your database home once and deploy it many, many times in a really, really fast way. Because you have centralized it, you just need your production cluster to say, well, I want to use this database home, it's on this Grid Home Server, please get me this home and create a database out of it. Of course, this has tremendous impact on how you can update or patch, because you can basically do it on a push of a button. And you can do it for hundreds of databases at a time. Let me walk you through some scenarios right quick, and then we will see what that means. The Oracle Grid Home Server enables what we call rapid home provisioning. Rapid home provisioning describes the process of deploying an Oracle DB home based on what we call gold images stored on a central Grid Home Server. We have a distributed approach, just so you would know, but we are focusing here on the centralized one. So you have a gold image in your Grid Home Server, which is another cluster, but it's somewhat dedicated. It's a smaller cluster, it's dedicated to operate as a Grid Home Server, can do other things, but it's distinct, in my case, from the production cluster that you see on the top right. In this case, what the production cluster would do, it would connect to the Grid Home Server using an HA-NFS connectivity, and would then run the database homes based on an HA-NFS mounted home and create the database out of it. Now, I heard some frowning, or saw some frowning on some faces when I mentioned NFS. Well, it is not the same as an NFS filer approach. It's more sophisticated by administration standards, and we will be using a direct NFS-based approach. That means our NFS client is already highly available. We have a highly available IP connectivity to the Grid Home Server from the client. So if an IP error occurs, we will not be impacted. There will be further enhancements to even make it more stable, but for now it is an HA-NFS connectivity, and I know some of our customers do use NFS connectivity on the filer. However, we do more than just mounting an NFS-based home, because we have a client-server integration which provides additional benefits over just using an NFS approach. I'll come back to this when I show you how it actually works in very high level. What I want to point out is, once you deploy your database homes on this centralized server, patching and updates get extremely simple, because you can actually increase the patch version on your Grid Home Server. You install a new home, a later version home on your Grid Home Server, and you make the client adopt the new home on a push of a button or by issuing one command. I'll show you this command in the next slide. What that means is you can update a Grid Home client either from the server, at least so the plan. Currently the client has to request an update actively to the server. When we implement it fully, it will also allow you to group your upgrades. It will say, okay, I want to have these number of Grid Home clients to be upgraded to the newer version at once. And you can group those clients, for example, per application. Now, how that works in very high-level terms. First thing you need to do is you use a grid infrastructure-based cluster to deploy your Grid Home server. I have used a little machine here on the top left, which could be an Oracle database of products. And then you have your production cluster, which I've shown in the top right, where you have eventually your databases run. You will store a gold image using a ghctl command on the Grid Home server. And this command is very important because it interacts with the Grid Home client, even though it may run on the Grid Home server. The Grid Home server and the Grid Home client stay in interconnectivity. They know about each other. As a matter of fact, the Grid Home server maintains what Grid Home clients are using the Grid Home server in a management TB. So if you provide a new version, what we will do internally on the Grid Home server, we will put this new database home on an ACFS-based file system and create a working copy with ACFS snapshots. So all technology we already have is utilized here. But the real magic, which is why I say it's more than just a NFS approach, pardon me, is this command that I have outlined here in this gray box, ghctl add working copy. This command can be run on the server for a client. And if you look through the options, it basically says the client should be using a certain version of the database home, copy it in a certain working copy. This is a working copy. And you can tell the client under which path this home is being mounted on the client, which is the path option. And that way you can, from the server, push a new database home to the client. And the same command, as it interacts with the client, is meant to stop the database and start it under the new home. So this is why it's more than a simple NFS remount. It interacts between the production client, at least when it will be available. Right now, if you happen to be a beta customer, you can't. This is a new approach to patching, and I encourage it early enough. I want you to look at it, because if you can use it, you may be able to better integrate your racks into your data center. However, we have helped you with the latter. We have provided quite a few new features to make rack better integrate into the data center and make it easier for you to manage it. The basic idea here is similar to what I've just introduced, is a centralized management. And the centralized management may be a dedicated cluster, maybe a dedicated server, but the problem with the server is if you have centralized management and it becomes crucial to you, you want to have this thing to be highly available. So what I'm saying here, and it's not a new product, it's a new way of deploying things. I propose to have a dedicated cluster, which we call the utility cluster in my case, which could be a cluster based on an Oracle database appliance, for example, and use it as a centralized management system. You can use it for Grid Home Server if you wish to do this, or you can use it for example, Oracle Enterprise Manager. Who of you uses Oracle Enterprise Manager across the data center? Where do you put it? A lot of you will put it in a high availability cluster. Well, here you go. You have a need for it. We also know that a lot of you use shared systems to maintain IP, naming, LDAP, DHCPs. Well, you can put it on the utility cluster. We have agents, John is going to talk about it, which will make it easier for you, for example, to provide high availability for web servers if you wish to have them. Oracle VM Manager. More and more of our customers are deploying Oracle VM in their data center. Now, I'm not saying they do it for rack or not. This is not the discussion. The point is that Oracle VM the Oracle VM Manager becomes a crucial management entity if you deploy Oracle VM. You want to have this manager being highly available so you can put it on a cluster. Here we go. The utility cluster can be used for it. And last but not least, you can use it for centralized storage or for the Grid Home Server, as I just said. Now, talking about IPs, talking about naming, some of you may know about a feature that is called Grid Naming Service. And we introduced this feature in 11.2. However, what we really introduced at the time was the idea to use dynamic IP management and name resolution. If you have hundreds of production clusters, what you ideally want to do is you don't want to take care of assigning an IP to each node manually. You want to have a mechanism that an IP can be generated automatically, and then the name would resolve automatically, dynamically for those IPs. This feature, which we introduced with 11g2, enables this. It's not a feature by itself, it's an enabler for you having the ability to use dynamic IPs and dynamic name resolution. It's called grid naming service. And unlike in 11g2, where we introduced the feature, you can now have one grid naming service for all your clusters in your data center. Can you imagine? You have 50 production clusters and you don't have to take care of IP management and naming anymore once you have deployed a shared GNS server. Now, how would that work? We would expect you use either DHCP for IPv4 networks, or if you already switched or are planning to switch to IPv6, you can actually use the stateless auto configuration to automatically generate IPs and then take care of the name resolution. And if you have looked into IPv6, this will be more and more the standard. You won't use a DHCP server for dynamic IP assignment anymore. You would be using stateless auto configuration. So the only thing you need to set up on the utility cluster you already have is the shared grid naming service, and you can use dynamic IP resolution throughout your whole data center. You install once, you don't have ever to ask for an IP again. Now that said, there is another new feature which we have received feedback on. With Oracle 12crac, Oracle RAC will be able to support IPv6 networks for client connectivity. In 11g2, the VIPs that we use to connect to a cluster don't support IPv6. In 12c they will, for client connectivity. That is to say, the interconnect will remain IPv6, but the clients can connect the interconnect will remain IPv4. The clients, however, can connect IPv6 to the cluster. In this context, have some of you the plan to switch to IPv6 networks through your enterprise, through your data center? Oh, that's again a good 3% of you. Thank you. Now, in this context, and I will talk about this in my session tomorrow at 11:15, Understanding Oracle RAC Internals, we have enhanced the scan. I believe most of you are familiar with scan. It was one of the features which eventually got really appreciated, however, introduced quite a bit of a change when we put it into 11g2. And what we did with 11g2 is we supported scan on one network, the default network in the cluster, for public communication. And one of the main feedbacks we have received is, why don't you have a scan per network that you support in the cluster? You can support multiple networks for public communication in the cluster. Why don't you do that for scan? Here we go. In 12c, we will have a per subnet multiple scan support for public connectivity. And next I want to mention two minor features just to show you the small features we have integrated but have a big impact. And I'm probably addressing the Windows customers first, or in particular later. What we have done is in 12Cs we have restricted service registration. Now that may sound a bit abstract to you. Basically what it means is it allows or it restricts clients from accessing a database registered with an Oracle Grid Infrastructure managed listener using various conditions. Well, that's again very techy. You may have heard about this security issue that we had issued lately, where a database can register with any listener that it can access. And we have enhanced, a lot of things. I see some nodding heads there, so I guess I know what you know what I'm talking about. So this kind of security is now solved because you can restrict the grid infrastructure managed listener to not accept connectivity or registration from arbitrary databases. We have solved the security issue by giving you the option to use the advanced security option in 11g2. In 12c, it's by design. You can restrict listeners to accept registration from database instances, you need to have them pre-registered, so to say, you need to inform the listener that this database instance can be connecting to it. And last but not least, a Windows enhancement, just so that some of our Windows customer would see that we have worked on one of the major requests. We now support named user support for Oracle RAC services on Windows, which is to say you don't always have to run the RAC services as a system user, you can use named services. Last but not least, and talking about data center integration, we have improved installation and upgrade. I talked about it a bit, but I want to now focus on the fundamental things that we do with the installer. So we always had the idea to say we install once, deploy many times. So we have done things to add node, and most of the installations, upgrade enhancements were actually introduced with Oracle RAC 11 Release 2. The latest version offers multi-purpose installation. We have a new concept in Oracle 12c stack, which is based on grid infrastructure, and John is going to talk about it in a minute, which is called Flex Cluster. Now, every time we introduce a new concept, we should make it happen that the installer can actually install it through initial install. And we did this time, so the 12c installer is set up to install most of the common Oracle RAC deployment models during first install, so you wouldn't have to go and change your installation after you've actually performed it. Another feature is very interesting. It regards running root scripts, or for that matter, fix-up scripts. If you have ever installed a grid infrastructure on a bigger cluster, and that may be already 3 or 4 or 5 nodes, what you had to do is, in the last steps of the grid infrastructure installation, you had to run fix-up scripts should your nodes not have been prepared properly, but certainly you had to run the root sh. I guess you know the root sh. Now we have given you a way to run root sh automatically. Well, that is to say, you need to provide the installer, as shown here, with either sudo rights or the root password, and then the installer will run the fix-up scripts or the root scripts across the cluster for you. So no more login to every node in the cluster during installation. You just let the installer do it for you. And that basically concludes the enhancements that I want to talk about today for the Oracle RAC database. I want to show you how the stack can be used for any application, and this is a major enhancement that we have. So far I've shown you how we have improved the stack to make it high available for the database. Small changes, big impact. John is showing you big changes, big impact. Yes.
Great. Testing. Hey, great. Hi. So Marcus, you stole my thunder. I mean, many of the features and functionality that you just described, in fact, what I'll call differentiating features and functionality, is implemented at the clusterware layer and exploited at the application layer. And the database and the RAC database, from my perspective, is just another application. And Marcus has alluded to flexibility, scalability, manageability, and availability. Each of those are features and functionalities coming out of the grid infrastructure, and specifically the clusterware. So when you're talking about the red stack integration, we are moving upward. So what does that look like in terms of the clusterware? In 12c, we're introducing Flex Cluster, which is, from our perspective, an innovative technology in terms of clustering, where we are providing a tightly coupled database tier integrated with a loosely coupled application tier. Essentially, it's assigning role nodes in a clustered environment where the application is referred to as a leaf node, which is loosely coupled and doesn't have the requirements expected of a database node or a hub node. So in this two-tiered environment, the hub node is your traditional cluster, tightly coupled in terms of communication and the requirements of shared storage to preserve the consistency model of a RAC database. The leaf nodes we can play with. They are loosely coupled. They do not have peer-to-peer communication, unlike the hub nodes. They do not have direct access to disks. And as a consequence, there is no voting file. And we expect these particular servers to be customized in terms of the applications running in them. So they're more oriented towards high CPU, high memory requirements, and less so in terms of storage. So we're going to do what we do best in the database tier, in the application tier. We're going to preserve business continuity and high availability. So Marcus has described some of that functionality in terms of the database. But from an application perspective, we can do the same thing. So for example, in the leaf tier or the application tier, here we've got Apache and Tomcat running. So in terms of planned and unplanned outage, we can manage it much better. So unplanned outage, you have all of the failover and restart semantics that you possibly could have in the database tier. But you also have the online relocation to manage planned outages. So for example, if I needed to take that server down for either OS or hardware maintenance, relocate the applications running on that server to a peer leaf server. Not only that, we exploit the concept of policy management. You can carve up this larger cluster into server pools, which preserves the isolation and role separation that you would expect in the database. So each tier, so for example, the web tier or the application tier, will have adequate role separation, isolated from the database. Carving them up into server pools allows you to implement the policy management that Marcus referred to earlier, not just for the database, but for the application tier. So you can impose policies in the application tier to change the server pool topologies. But it's not just intra-pool or intra-tier management, but it's inter-tier management. So you can move servers, not just within a particular application tier and those server pools in that application tier, but you can move servers between the tiers to increase or modify compute power at the database tier. And as Marcus mentioned, when you're managing a large number of resources, either as a consequence of large scalability or density of consolidation in a clustered environment, you want to know, where are my resources? And will I have my resources where I want them, when I want them? And he described what-if analysis in terms of the database. You have that same functionality in the application tier for any resource. So you have it at the resource level, the server pool level, and the server level. So if I'm planning a maintenance on, again, another server, I run a what-if analysis and say, where are my resources going? And what is the consequence of that displacement on the nodes that they will be placed on? And then he's also described the management across applications in the grid home server. And he speaks of it in terms of the database, but it's not isolated to the database. You can store gold image deployment models for your applications. Rolling through the application tier, updating your application software. If, and most, as the momentum moves towards virtualization in the application tier, the grid home server can provide template service as well for OVMs. Now this is the compelling reason for coupling the application and the database in a single clustered environment. Customers have asked us repeatedly, we need to couple the application with the database so that when the database comes up, or when the application comes up, everything that's required for that application is in place. And that's not just the infrastructure, not just the network or the storage, but also the database. And when you are in a consistent cluster, you can impose a dependency model and say, okay, when my application starts up, I want the database to start as well, or vice versa. As the database comes up, I want the application to come up. And let's say you're Siebel. For those of you that are familiar with the Siebel architecture, you've got to be sure that the Siebel gateway name server is up before the Siebel servers come up. So not only are you doing inter-tier dependency, but you're doing intra-tier dependencies as well. And then bundled agents. So a mechanism to control the start, stop, and check of the application. So at 3:30 this afternoon and 3:01, I will describe our growing portfolio of agents for the application tier, and I would welcome you to attend. I'll reserve further description for that meeting. So how does it work? Well, it's an asymmetric cluster. Think of a bicycle. So if you think of a spoke, one end is coupled to the rim and the other end is coupled to the hub. It's a similar architecture where you have a leaf node communicating with a hub node in the cluster. Not exclusively. In the event of failure, the leaf node would connect to another hub node in the cluster. There's no communication between leaf nodes. The failover semantics, the fencing semantics for the leaf node is entirely different from the database because we have no risk of corruption, or we don't need to maintain the consistency model in the leaf tier as we would need to preserve the hub tier. There is no shared storage, so I've already mentioned there's no voting disk, there's no OCR. However, the applications, the application tier, can still use the local storage or NFS-mounted storage, even an ACFS-exported NFS mount. So we expect the database to be on the hub tier, and transaction I/O coming out of the application tier to be processed through the database tier. And these clients can have segregated subnets with high availability network access. So that's what we're doing in 12c for the application tier. So I'll turn it back to Marcus.
Thank you, John. We have 5 more minutes for questions and answers here. I encourage you to come to the microphones, but beforehand, I want to thank for your attention, and we will be available on the demo grounds and tomorrow. Thank you.